Record now. Hello everyone, welcome to my channel. This is 24 game. Leetcode 679. This is a hard problem asked recently by ByteDance, Google, and HRT. I wonder what HRT is. Anyways, you are given an integer array cards of length 4. Okay, let's go. Now you have 4 cards, each containing a number in a range 1 to 9. You should arrange the number of cards on these. Sorry, you should arrange the numbers on these cards in a mathematical expression using the operators plus minus the asterisk, right, which is multiplication, and there's a division sign also, and parentheses, right, open and close, to get the value 24. So that's what the question is about. So trying to find possible combinations of your string, sorry, whatever you've been given, the numbers you've been given to get 24. This is interesting. So we have a few rules I have to follow. The first is the division operator represents real division, not integer division. Okay, so we want real division, right? So I see. So 4. Now normally, if you had like 4 divided by let's say 5, right, you'd want 0.8, right? That's what you want. If you were doing that normal division, so when you do it by Java, it's going to do 4 divided by 5 and going to give you 0, right? So it's going to floor your division basically. So I think that's not what we want. We want the one which will give you a double. So eventually, when we are solving, we will need to use the double. Okay, so every operation is done between two numbers, right? In particular, we cannot use minus as a unary operator. Okay, cool. So we have if cards 1 1 1 1 1, it can be like minus. Oh, okay. I see. So we can have negative some number, right? We have to use negative, right? The negative sign in between two numbers, basically. That's what it's saying. And you cannot concatenate numbers together, right? Okay, so for example, cards 1 2 1 2, well, the expression 12 plus 12 is not fine. Okay, cool. Return true if you can get an expression that evaluates 24, and false otherwise. So basically, I think the question is leaning more towards this is crazy, a crackhead problem, basically. It's going to be a hard problem to solve if you are thinking of using the parentheses, because this is similar to a different Leetcode hard question, right? Which is and I think it's called expression add operators, right? Which is a whole kind of forms. But I think in this problem, if you want to look at it in terms of we are doing combinations based on the strings we have, right, then that will be helpful. So let's go to the whiteboard. Previous I hope this recording is actually so right, so we're on the whiteboard, and I'm sorry I got a bit distracted there, but the example, right, that we're given in the question, right, we had the first example, we have 4, and oh my god, I don't know if to use this too much. So we have 4, we have 1, we have 8, and then we have, I believe, 7, right? So that is the numbers we have, and 7. So what we want to do is to, if we are exploring, right, we pick 2 numbers and work with them, right? Instead of, you forget about using the parentheses, pick 2 numbers and work with them. So basically, let's say we took 4 and 1, right? We go through all the possible all the possible computations we could do for this. So we could do a 4 plus 1, right, which is 5. We could do a 4 minus 1, which is what, 3, I think. Oh, looks bad. Okay, anyway, we could do a 1 minus 4, which is what, negative 3, right? And then we could do also, dividing, right? So 4 divided by 1, in this case is going to be 4, and then 1 divided by 4, which is what, 0.25. And then also we could lastly do what, 4 times 1, which is 4. No matter how you slice it. So basically the plus and the multiplication, because they are commutative, right? So we just do them once. We don't have to switch it around. So basically, if we did this computation, right, and we chose any of this computation, then we want to have a new list, say 5, 8, and 7, right? And do our DFS basically on it. So then we also go through all the possible computations between these two. Whatever answer they spell right, and we whatever branch of the tree we choose, right? Then we choose that part and then do computations with 7 basically. So maybe let's say we chose 5 times 8, and that's 40, right? Then we do it with 7 basically. So this becomes our new array, 40 and 7. So in the end, we'll be changing and decreasing our array, right? The first element we want to be the computation we are dealing with, and then everything else, and then look for it. So basically, we're going to have a DFS tree, right? We're going to solve this with backtracking on DFS, and this is how it's going to be built, right? So we take 2 numbers, find out the possible computation between them, and then we explore the tree based on those computations, right? And we'll explore more computation. So you see, as we keep exploring, right? We have 6 computations to explore, and we will have to explore them at least n times, right? Already giving you an idea of what the runtime will be, and I think the runtime of our solution in total is what, n square, and you'll see why it's n square by what, 6 to the power n, right? So I hope this was a little bit more informative. Let's get to the coding. So we're back on the code. I hope the session was helpful. Now we're going to explore everything. If we hit one that gives us true, we return true. Basically, that's what we want. So now we have we want to give the basic elements of stuff that we want, right? So I want to have our DFS, right? DFS, and DFS will take cards. And actually, before I was speaking and saying that we need to use doubles, because if you use doubles, right, then we are able to handle the floor division part. So what we want to do is make a double array, call it cards, and I will just call it cards double, right? And it's basically it's going to put everything in cards, basically in it, right? And it's going to convert them into doubles, right? So cards 1, cards 2, and cards 3, right? So every element. This was just 4 elements, so it shouldn't be hard to do. And also, what we want is to call our DFS function, right? Let's call our DFS. I think I want our DFS function to be a boolean, right? So what we also want to do is keep, we have one cards, right? We want now cards double, actually. That's what we want. And then we want the number of cards that we'll be doing. So you see, as if you go back to the illustration, right? As we do a computation, we have less elements in resulting arrays, right? So in each step, we'll decrease the number of arrays number of elements we have in our array, right? So once that number of elements we decrease and it eventually hits 1, right? Then we know that we have essentially what we want, which is our value, right? Or our result. Now, if our result is equal to 24, then fine, that's what we want. So n, but so the number is n, and then we also want initially our value, right? We'll be keeping a value so we can just check it here, right? We can check it. So that we also want the value, and let me see. Actually, I think that's it. Basically, I might be wrong. So if you need anything from our DFS, we'll probably call it again. So we'll probably just rename. So basically, DFS of a boolean, and then we have a double of our cards double, right? And then we have the number of elements, and then we have our file. Right. So what we want to do is write our base case, right? So if n is equal to 0, right? So if n is equal to 1, meaning like now we've done all the possible computations, and then we have just one element in our list, right? If so, then what we want to check if it's equal to 24, right? So basically, because we are dealing with doubles, though, there might be like numerical approximations that you have to make, right? So maybe it's not necessarily equal to 24, maybe it's like 24.001 or so and so forth. So what I want to do is to say that if the math or amps, right, of our value, the value we get minus 24, if it's within 24 by 0.001 or a small number, right, then we can return true, right? If not, then we want to return false. That's it. Okay, so that said, we want to do have a for loop where we have int I, right, running from actually instead of me calling the cards double here, let me just make it cards so it's easy. Okay, so cards.length is going to go to cards.length and I plus plus, and then for j should start from I plus 1. So basically, we want to take 2 elements at once, right? So this is one of the best ways to do that. And then we'll temporarily keep values for our numbers. So we say temp1 is equal to what, cards I, and double temp2 is equal to cards j. Now we want to build our subsequent array, right, that we'll use later on, because we've done already a few computations already. So what I want to do is that array, right, that double array, I want to call it new cards, right? And that one has a length of whatever we have, right, which is cards.length minus 1, right? Because if 2 things combine to become 1, they become 1, and then there are 2 other things in the cards, right? Therefore, we have 4 cards initially. 2 combined, they give us 1 value, right? We keep that 1 value, and then there'll be 2 other values. So 2 plus 1 is 3, right? So basically, the resulting array will always be 1 less than the current array we have, right? So basically, what we want to do is to fill, but I want to start filling from what, index 1 going on, and then index 0, right? You can do it the other way around where you have it at the end. But basically, index 0, what we want to do is index 0 is equal to the value, right, that we have. So the value we have in between computation. So basically, let's say I picked 8 and I picked 4, right? For this example, I picked 8 and I picked 4, right? Then I want 1 and 7, which is untouched, to be there. And now 8 minus 4, right, for that particular computation, that value will be at the beginning. So that, I think 8 minus 4 is what, 4. So it would be like something like 4, 1, 7, right? And then we'll do computations based on that one recursively, right? So I have index plus 1, and then I'll say 4 in C, right? And C is going to start from the beginning of the card. So C minus cards.length and C plus plus, right? Now, if our C is not equal to what, I, right? And it's either also not equal to J, right? It's not the same index as our I and J, which are taken as our temps now. If it's not, then we can add it to our new cards, right? And then we'll increase the index like as it goes on. So basically, we'll say what, card C, right? So it's equal to card C. Basically, we copy the rest, right? So let me name this here, actually. So we're building the next array, basically. So now we want to get the computations, right? And to get the computations, I will want to say the double and I call it computations, and call this function gets computations. Basically, and get computations, we give it the temp or the cards that we are currently picked, right? And to do computations based on those two cards, right? So get computations is here. And actually, let's just step out and define the computations right now. Right? So it's going to give us a double array. Call it get compute. So capital C computations, and we'll call it int A, int B. Actually, they are not int, they are doubles, right? Sorry about that. So actually, small. Oh, typos. Double A, double B, right? And then we have this, right, which is list new. Basically, actually, we can just have the computations in there, right? So we'll say that we want A plus B, right? And A times B, because these are commutative. Right now, A divided by B, B divided by A, and I think A minus B and B minus A, right? So this is it, and then you want to return list essentially. Right? So that's what get computations is going to do. So you want to give us all the possible computations we can do with these numbers, right? And now once we have those computations, we want to put that as an element in in our new cards essentially, and then pass new cards as an argument in our DFS, replacing cards, right? So that's what we want to do. So I want to say, actually computations. Okay, cool. So get computations. We are getting on the computations now. Use computations like this. So we are going to loop through all the possible computations. Right? So we have double computation, right? In computations. Now I want to set computation to, sorry, new cards 0, right, towards computation. And then we'll do a DFS and check if it works out, right? So we'll say if DFS new cards, right? New cards is passed instead of what cards, so I replaces cards. And then we have new cards. Also, I need our n to reduce by 1, right? Because yeah, exactly. Every time we do a computation, we reduce our n by 1. And also our val, now our val is actually equal to whatever computation we have here, right? So we'll say our val is equal to computation, right? Now if that returns true, then return true. Right? Else, I want you guys to backtrack. And when you're backtracking, we change the initial element of the new cards to 0, right? So do backtrack and change it to 0, right? And try add out possible computation basically. So backtracking here. That looks good. So if our whole for loop executes and whenever it hits true, what we want to do is what return false. And basically that's it. Hope you guys can follow the logic. Ooh, loosely double to int. Okay, I made a mistake somewhere. So we have int n, but val is sorry. So val is supposed to be a double. And actually, let me say 0.00. That's one. Let's go. No return statement. Hold on. Okay, so no return statement. I guess my return false is in the for loop instead of not being outside it, right? So that was a mistake. Right. So it worked for the first test case. So basically, to go through all the possible computations and combinations, basically. That's why you need DFS, you need backtracking. And actually, the constraints is a good giveaway. This is a very hard question. If you went and were trying to use the parentheses, you can just forget the parentheses and try to do computations with every two numbers, and then your list keeps reducing as time goes on. So we passed all the test cases. We beat 99%, actually 98% of users with Java. So this can go. This is very good. And now you guys are guessing what's the runtime. So let's go through the code and look at the runtime, right? So basically, the main call here was what our DFS call, right? Now in our DFS call, this can be done in all one time, right? Just checking the val against 24, seeing the difference and returning true or false based on that. Right? But now here we loop through cards twice essentially. So this is an O of n squared looping, right? And in our O of n looping, we also have this DFS call. So what does our DFS call do? Right? Our DFS call is called here when we have computation. The computations, note that we always have 6 different computations, right? So for 6 of them, we are doing this. This is basically like we have 6 decisions that we are making, right? So think of it, we have 6 decisions. I'm making those 6 decisions essentially n times, right? I'm making those decisions 4 times, right? So 6 decisions times, because our n is very small. N is what, 4 in this case, but let's say we're keeping it strictly in n's, right? It's going to be 6 to the power n computations. Now that's crazy. Okay, so basically you have an n cube times 6 to the power n computation. Let me just add this here, right? Our runtime, yeah, runtime n. Also, I said n cube, right? So we have right n and we okay, so we have, yeah, exactly. So it's n squared, right? N squared times 6 to the power n, right? And why am I ignoring this for loop, right? Because basically this for loop is O of n, right? It's going to be O of n minus 1, basically like almost O of n, except that this computation where we are having 6 to the power n is way greater than O of n, right? So basically it's O of n squared times 6 to the power what? O of n, 6 to the power n. That's your runtime in O standard notation. right? But I hope you guys, can see this. I hope this video wasn't too long. Probably yes. This is a legal hard question, so forgive me. Hope it was beneficial and helpful. If you like, subscribe. Let me hear from you guys. Thank you.